Hi, welcome back. In this video, I will explain about energy band theory. Just now we have discussed the atom structure. Every atom consists of nucleus and orbits. From that orbits, the band structure is defined like this. Now I'm drawing atom band structure. Every atom has depends on the atom numbers. Every atom has a different number of orbits. So this is considered first orbit band, and second orbit band, and later third orbit, and finally it has one band. This band is called outermost orbit band. So outermost orbit band is also called as valency band. Outermost orbit band is called valency band. So now onwards we are writing this band as a valency band, and just I'm writing the representation is like this: VB. The electrons in valency band are bonding electrons. So we can write here valence electrons or bonding electrons. Those are not free electrons. Next level is completely comes under free band, right? So that band is also called as conduction band. So after the valency band, one more band is available. That band is conduction band. Conduction band electrons are free electrons. So now onwards I will write as like CB. CB is nothing but conduction band. In conduction band, all the electrons are free electrons. Free electrons. So the electrons are moved from one place to another place without giving any external energy. So those type of electrons are called free electrons. So valency band electrons, valency electrons are bonding electrons, and conduction band electrons are free electrons. According to the atom structure, the outermost orbit electrons are called valency electrons, and those electrons are bonding electrons and fixed electrons, and due to some external energy the bond breaks there. If the bond breaks, then all the electrons becomes a free electrons. Then the electrons are jumps from valency band to conduction band, and in between it has some gap. This gap is also called as energy gap. This gap is also called as energy gap. Then another name of this energy gap is forbidden energy gap. Now onwards I will write as EG. EG is nothing but forbidden energy gap. So it is a gap between, it is the energy gap between the conduction band and valency band. So the definition of the forbidden energy gap explains the energy gap between the conduction band and valency band is called forbidden energy gap. This band is a valency band. So just I'm writing as this VB, valency band. And after this, one more band is available. That band is called conduction band. This band is a conduction band. The gap between these two is called forbidden energy gap. And the lower energy level of the conduction band is EC. Just I'm representing with EC here. EC is nothing but lower energy level of conduction band. So conduction band starts from this energy level. So that level is EC. And higher energy level of valency band is EV now. So this is the border of the valency band. Now valency band is available up to this energy level. So higher energy level of the valency band is EV, and lower energy level of the conduction band is AC. Then the energy gap EZ is equal to EC minus EV, because the definition explains it is the gap between energy gap between the conduction band and valency band. And we can write some other definition, that is the minimum energy required to move an electron from valency band to conduction band. The minimum energy required to move an electron from valency band to conduction band is called forbidden energy gap. This is also another definition, one of the definition. And this energy gap is again depends on the atom number, and it is depends on the temperature also. That's why we can write one standard formula like this: energy gap of any atom is defined from this equation. That equation explains Eg is equal to Eg naught minus beta into T. Eg naught minus beta into T. Here Eg naught is energy gap at absolute temperature. The energy gap at 0 degree Kelvin is called Eg naught, and beta is a constant. This is depends on the type of the atom. Beta is a constant, and T is temperature in kelvins. Temperature in kelvins. So now onwards, remember, wherever the T is there, immediately we have to take the temperature in kelvins representation only, not in centigrades. So always you have to write in terms of kelvins. So your energy gap of any atom is defined from this equation. So energy gap equation explains the Eg naught minus Bt. Eg naught is the energy gap at 0 degree kelvins, beta is constant value, and the T is temperature in kelvins. Now I will write the standard energy gap values of the few materials, like few atoms. Those are silicon and germanium. Because now onwards we have to use these atoms, right? So silicon and germanium I am writing now. Silicon atom number is 14 and germanium atom number is 32. Silicon atom number is 14, germanium atom number is 32. The energy gap at 0 degree kelvins, Eg naught value of silicon is 1.21 electrovolt, and the energy gap of germanium, absolute energy gap, right, at absolute temperature. So energy gap of germanium at absolute temperature is 0.785 electrovolt. 0.785 electrovolt. These are the standard energy gap values of the silicon and germanium, and these values are defined at absolute temperature. And beta value. Beta is a constant value. This value is 3.6 into 10 to the power of minus 4. 3.6 into 10 to the power of minus 4 electrovolt per Kelvin. And similarly, this value explains the 2.23 into 10 to the power of minus 4 electrovolt per Kelvin. These are the some constant value. If you substitute these values in this equation, in this above equation, equation number 1, let us write this is equation number 1. T is a temperature in kelvins. Now I want to write the energy gap of semiconductor and energy gap of silicon and germanium at room temperature. At room temperature means at 300 degree kelvins. At 300 degree kelvins, the silicon energy gap becomes 1.1 electrovolt and germanium becomes here 0.72 electrovolt. So if the temperature is increases, the energy gap is decreases here. According to the Fordham energy gap, the materials are classified into 3 types. Those are conductor, semiconductor, insulator. So in this video, just I have explained the basic energy band theory and what is Fordham energy gap and the standard equation of Fordham energy gap. In next video, I will explain that concept conductor, semiconductor and insulator. Please take this now.